Hi guys, example 3.2 from chapter 3 part 2 under loading distribution subtopic. The question is, determine the characteristic permanent action GK and variable action QK on beam B13 given the following data. Unit weight of concrete is 25 kN per meter cube. Finishes, ceiling and services 2 kN per meter square. Variable action for all slab is 3 kN per meter square. So this is the floor plan B13. So this is the beam B13. Given the size beam is the width of the beam is 200 mm and the depth of the beam is 500 mm. Meanwhile, for all slab, thickness is 150 mm. Solution. The first step, we need to determine GK and QK on slab. So this is action on slab. Self-weight for slab is thickness multiplied with the unit weight of concrete. The answer is 3.75 kN per meter square. Finishes, ceiling and services as given in the questions is 2 kN per meter square. And characteristic permanent action GK for slab is the total of 3.75 and 2 kN per meter square. The answer is 4.75 kN per meter square. Meanwhile, for the characteristic variable action QK given in the questions, 3 kN per meter square. For all slab, the load GK permanent variable action is 5.75 and for the variable action for all slab is 3 kN per meter square. Next, we need to distribute this 5.75 and 3 kN per meter square to beam B13. Before that, we need to determine either this slab and this slab and this slab is one-way slab or two-way slab. Our next step is to determine the direction of the load distribution. The first floor. This is the first slab, FS1. FS1, Ly divided by Lx. FS1. 3 plus 4.5 is 7.5 meter. Meanwhile, this side is 2.5 meter. So meaning here is Lx and here is Ly for slab FS1. So 7.5 divided by 2 is equal to 3, which is more than 2. This slab is one-way slab. Meanwhile, for slab number 2, Ly divided by Lx. So this is slab number 2. 3 meter and 4 meter. Here is Ly and here is Lx. 4 divided by 3 is equal to 1.33, less than 2. So this slab is two-way slab. The third slab, Ly divided by Lx. So this is the third slab. 4.5 and 4. This side is Lx and this side is Ly for slab number 3. 4.5 divided by 4 is equal to 1.13, which is less than 2. Thus, slab number 3 is two-way slab. We continue. So for slab number 1, is one-way slab. This is one-way slab. Slab number 2 is two-way slab. Same with slab number 3. So we draw the distribution like this. So half load go to beam B1, 3, and another half load from this slab distributed to beam A1, 3. Meanwhile, for slab number 2, this is slab number 2. So the two-way slab, this is the 4 and 3 meter. The shorter slab, the shorter length, shorter beam will receive this shape. So this is trapezium like this. Okay, so for this slab number 3, this is the shortest length, this is the longest length. So here is triangle, so this is trapezium. So this is the distribution. This is slab number 3. This is slab number 2. And slab number 1. Okay, for slab number 1, action from slab, distribute to beam. So this is number 1. We have two options. No option, sorry. So the first, for the one-way slab, so the equation is W is 0.5 multiplied with the load multiplied with the Lx. So this is the equation. The final unit should be in kilonewton per meter. So we have here is for GK is 0.5. Our previous GK is 5.75. 5.75 multiply with here the length of Lx is 2.5. So the answer is 7.19 kilonewton per meter. Meanwhile, for QK is 0.5. The load for QK we calculated earlier is 3. Lx is same. So answer for QK is 3.75 kilonewton per meter. Next we calculate slab number 2. For slab number 2, we have two options because this is two-way slab. Our first option is using this equation. And Lx divided by 3. Or we can use table 3.15 using coefficient, and the equation is beta v y multiply with n multiply with lx. So solution for this example, we use this equation from table 3.15 BS 8110. So GK for slab number 2 is the coefficient in y direction multiply with the load GK, which is 5.75, multiply with LX. So this is later I will show you. So multiply with 5.75 multiply with 2, sorry, so here is 3, here is 4, so meaning our LX here for beam here is 3, so multiply with 3. So our beta Vy here we refer to table 3.5. So this is table 3.5 for standard BS 811. Shear force coefficient for uniformly loaded rectangular panel supported by on 4 sides with provision for torsion at corner. So as we can see here, so this is our slab. This side and this side is continuous with other slab. Meanwhile, this side and this side is discontinuous. The long edge continuous with this slab, the short edge continuous with this slab. Meanwhile, for the long edge and short edge at this side is discontinuous. So when we look back at table 3.5, it is for case number 4. 2 adjacent edges discontinuous. So under this case, so we have 2 continuous edge and also discontinuous edge. So we look back here. This is the beam. This beam is connected with the continuous edge. This beam is continuous with this slab. So meaning from this table, case number 4, we use this one, continuous edge. And according to this one, we have 0.4 until 0.6. This is for beta Vx. So our beta is beta BVy here. So meaning our value for 2 adjacent edge discontinuous, for continuous edge is 4. So this is the value 0.40. And the answer here is 6.90 kilonewton per meter. Meanwhile, for QK, 0.4 multiply with the previous calculated QK, which is 3.0, multiply with 3 LX. So the answer is 3.60 kilonewton per meter. Okay, done for slab number 2. Next, we check for slab number 3. So for slab number 3, two-way slab, there are two options. So the first option is for the trapezium two-way slab. The equation is W3. W3 is referred 3 is for slab number 3. Okay, so and the load multiply with Lx divided by 6, 3. So this is the equation, power of 2. Or we can use table 3.5 BS 8110, and the equation is beta Vx multiply with the load multiply with Lx. So GK for slab number 3 is beta BV. Later we look at this. Multiply with the load. The load for GK we calculate earlier is 5.75. And Lx. Lx for slab number 3. So here is 4. And this H is 4.5. So our Lx is 4. So multiply with 4. So GK here refer to table 3.5. We have 9 cases. So refer back to floor plan. So this is slab number 3. So the long edge is continuous. The short edge here also discontinuous. Meanwhile, for this, both edges is discontinuous. So the same case with floor number 2. So we look back at table 3.15, case number 4. Case number 4. So here is the BVX. So which one we want to select? So this is referred to L divided by Lx, Ly divided by Lx. Okay, so this is two adjacent edges discontinuous. Two adjacent edges discontinuous. And this is the beam. This beam is continuous with the other floor. This floor and this floor is continuous. So in between is this beam. So this is continuous. So we select continuous edge. We have value 0.40 until 0.6. This selection is based on Ly divided by Lx. As calculated earlier, our Ly over Lx for floor number 3 is 1.13. Thus, this is 1.13. So 1.13 meaning for case number 4, continuous edge is 0.44. So we use 0.44. 0.44. And GK for slab number 3 is 10.12 kilonewton per meter. Meanwhile, for our QK is 0.44 multiply with 3 multiply with 4. So QK for slab number 3 is 5.28 kilonewton per meter. We have calculated the slab load distribute to this beam B13. So I draw this beam. So this is the beam. This number 1, column number 2, and column number 3. So this beam receive load from slab as calculated here. This is floor number 3, this is floor number 2, and this is floor number 1. So as we know, beam will receive GK and QK. For GK for beam is total of self-weight of beam plus load from slab plus brick wall. In our case, we don't have data for brick wall. So self-weight of the beam plus the load slab. We already calculate load slab. So we need to calculate self-weight of beam. So self-weight of beam, self-weight for beam is the width, the area, multiply with the B multiply with H. Please take note that this is the H. This here is 200, here is 500. And also we have slab thickness, which is 150. So here is B. And for depth, we need to minus 0.5. 500, 150. Multiply with the unit weight of concrete. So GK beam self-weight is 1.75 kilonewton per meter. So we already have all data. So we need to total it on the beam. So beam 1, 2. So beam 1, 2, this is beam 1, 2. Beam 1, 2 receive load slab from this slab and also this slab. Okay, so this slab for GK is 7.19. This slab GK is 6.9. Okay, so for this one, this slab, this beam will receive GK from slab number 1, which is, this is slab number 1, which is 7.19, plus GK from slab number 2, which is 6.90. Okay, so here is 7.19 plus 6.9 plus self-weight of the beam 1.75 GK. So total here is 15.84 kilonewton per meter. Meanwhile, for QK is QK for slab number 1 and QK for slab number 2. QK for slab number 1 is 3.75 and QK for slab number 2 is 3.60. So our QK here is 3.75 plus 3.60. So QK for this area, beam is 7.35 kilonewton per meter. Then for this area, this part, beam B13. So beam B13 receive load slab from slab number 1 and slab number 3. So GK for this span is 7.19 from slab number 1, 10.12 from slab number 3, and the staff weight of the beam. So we write here 7.19 plus 10.12 plus staff weight of the beam 1.75. So our GK here is 19.06 unit in kilonewton per meter. Meanwhile, for QK here, this span receive variable load from slab number 1 and variable load from slab number 2. Slab number 1 QK is 3.75. Meanwhile, for this slab is 5.28. Okay, so 3.75 plus 5.28, QK for this span is 9.03 unit in kilonewton per meter. Thus, for span B12, this is the QK, permanent action, and variable action for span B12 is 7.35. Meanwhile, for span B23, the permanent action is 19.06 kilonewton per meter, and the variable action is 9.03. So we have solved this problem. Thank you.